Awesome. So hope we are good to go. If I'm audible, please drop yes in the chat box. All right. So I'm audible. So hello and welcome everyone. Welcome to the Machine Learning Study Jam session 3. And before heading on to today's session, I would like to thank all of you for your positive and active response in both the session 1 and 2, which were held yesterday and today. And today's event and session has been brought to you in coordination with DSCs from ADIT, Charuset, GSET, and NLGIT. And today we have the leads from this chapter present with us. So starting with me, I am Hariom Yagnik, leading student community under GDSC at New Age Institute of Engineering and Technology. I'm Microsoft non-student ambassador since Jan 2021, and I am very much thankful to have this event in collaboration with my fellow leads. And we hope that we are able to pull this event some important session for you. Now, let's have a word from Vaishnavi Sonwani, GDSC lead from Charuset. Vaishnavi.
Hey, I'm going to use this Darth Vader as a bait again. Empire Strikes Again. All right, so I am Vaishnavi Sanone. I am the lead of GDSC Charu set. Again, my domain of interest is machine learning itself and computer vision. Apart from that, I am a writer. Check out my poems. I would be sharing my social media handles with you. Apart from that, I'm a part-time stand-up geek. And yeah, reach out to me anytime. I will try to respond as soon as possible. And looking forward to a great session.
That was awesome. Now let's have a word from Preet Thakkar, GDSC lead from ADIT. Preet.
Hello everyone, I'm Preet Thakkar. I am GDS lead from ADIT. I am TensorFlow certified developer. Also, I have done my specialization in deep learning from deeplearning.ai, an end-to-end company. And here are my social media handles. That is Preet Thakkar from LinkedIn. And I'm a web developer and server administrator at Hunt Digital Media Private Limited. And I don't have a data with me.
That was a funny point. Now let's have a word from Tar Dhamelia. He is a lead from GSET. Tar.
Hello everyone, myself Dad Damaya. I am a lead of GSET and also I am a web developer and open source contributor. If you guys have any query regarding anything of my domain, then you definitely help reach out to me. I will help you. Feel free to reach out. I hope last two session was amazing and let's enjoy today's session.
That was awesome. Folks, as you can see, we have some great talent with us, having some powerful knowledge of technology as well as the great humor. So, without any further ado, let's head on to today's session. And for today's session, we have Preet Thakkar as an host and speaker. And Preet will be covering some insightful knowledge on deep learning and neural networking. So, I'm handing over this session to Preet. Preet, you may take from here.
Hello. So, I believe you have attended previous sessions and are aware about the machine learning terms and aware about artificial intelligence terms too. So, I'll be starting with deep learning now. Okay, so this is a basic intro. Well, I'm not going to give it again. Here are the key points we're going to cover in this session. So, deep learning definition, some technical details, applications. Why do we need deep learning? What are neural networks? what happens inside hidden layer, supervised and unsupervised learning, types of neural networks, key principles of deep learning, what is regression, linear regression, logistic regression, and back propagation with gradient descent and loss function. So let's start directly with deep learning in a nutshell. So, well, we have two definitions. हिंदी में समझाए तो हमारे पास दो डेफिनेशन है, एक जो इंसानों को समझ में आती है और दूसरी जो किसी को समझ में नहीं आती। खैर इंटरव्यू को दूसरी वाली चाहिए होती है, तो आप लोग इसे रट्टा लगा के जाओ, हाथ पे लिख के जाओ, इंटरव्यू को कोई फर्क नहीं पड़ने वाला। सो फर्स्ट वन जो इंसानों को समझ में आती है वो कंसेप्चुअल डेफिनेशन। Deep learning is a machine learning technique that teaches computers to do what comes naturally to humans. Easy, right? जो इंसानों को समझ में आता है वही हमको कंप्यूटर्स को समझाना है। Now let's get the hard part. Deep learning is a class of machine learning algorithms in the form of neural network. It uses a cascade of layers of processing units to extract features from data and make predictive guesses about the new data. I know, समझ नहीं आया ना? So deep learning एक uh, layers का use करता है. So we'll be seeing these layers soon enough, and it processes this data and extracts some useful insights from the data. Let's say I'm giving a photo, my photo. What will be getting out would be how many wrinkles I have, what's the position of my nose, etc. And then it'll make some guesses about from my image, and maybe I can use that for security purposes, scanning my face, image mapping, anything. Okay, so now we're gonna study some deep learning theory. So we know system is dumb. So system is like a child. We need to make it understand everything from the basic, and then like it's from scratch. Okay, so it learns with big data. So however data you provide, it will learn it and will get better by data. But obviously, if you provide more data, it will get overfitted to certain data, which is real bad. I hope you remember overfitting from previous session. And trial and error guesses to adjust weights and biases and establish key features. It creates a predictive system to identify new examples. Same AI argument, big enough data makes a difference. Simple algorithm run over large data set. So consider a cat recognition algorithm. So we have a database, a dataset having images of cats. So I'll be providing it with 5 images first. So it'll have some hardship recognizing the data. And finally, I'll be providing more images, so it'll fit more. It'll recognize a cat more easily. But obviously, I have to take care that I don't provide it with more data, so it doesn't just recognize cats only and nothing else. Okay. Then comes another method, the trial and error method. The guesses to adjust node weights. So, what are weights? We're gonna learn in subsequent slides. Then comes the output. System identifies new examples. So as I said, we provide it with some data, and it recognizes if given data matches the data set you provided, the training data set we provided. Okay, so here's a sample task. So, for example, we create an image recognition model. How is it gonna work? The model first needs to be trained on test and training dataset. Sorry, it isn't a validation dataset, where it looks for minute features for the image. Let's say tires, windows, radiator, brand symbol, anything. So in layers, these things are recognized. For in the first level, low level features are recognized. For say, it first recognizes if the image has tires and windows. That these features are obviously available in the car. Then a mid-level feature, it recognizes mid-level features like if a radiator is available, is it visible in the image? Then the high-level feature, the minute features, then which may be a brand symbol, let's say BMW symbol, is it available there? Okay, so often These three terms, AI, ML, and deep learning, are interchanged and used as the same. So we're gonna learn the basic difference between between these three. So within a computer science discipline, in the field of artificial intelligence, this deep learning is a class of machine learning algorithms that are in the form of a neural networks. All the okay, sorry. So what exactly is AI, artificial intelligence? Humans have been obsessed with automation since the beginning of technology adoption. AI enables machine to think without any human intervention. It is a broad area of computer science. AI systems fall into three types: ANI, artificial narrow intelligence, which is goal oriented and programmed to perform a single task; AGI, artificial general intelligence, which allows machine to learn, understand, and act in a way that is indistinguishable from humans in a given situation. Is simple, but it allows a computer to mimic or behave like a human. एक कंप्यूटर को इंसानों के जैसा बोलना, आई मीन रिकॉग्नाइज करना, देखना सिखा सकता है. ASI, artificial super intelligence, is a hypothetical AI where machines are capable of exhibiting intelligence that surpass brightest humans. So often in movies we see there are robots which behave more intelligent than even humans. They take over the whole planet, which obviously the word has specified. They are still hypothetical. They haven't yet invented. If I pray if I live to see those robots. So these computers do jobs even humans can do. Okay. Then comes machine learning. Machine learning is a subset of AI that uses statistical learning algorithms to build smart systems. The machine learning systems can automatically learn and improve without explicitly being programmed. The recommendation systems on music and video streaming services are examples of machine learning. The machine learning algorithms are classified into three categories: supervised, unsupervised, and reinforcement learning. Then comes deep learning, the deepest part. This subset of artificial intelligence is a technique that is inspired by a way a human brain filters information. It is associated with learning from examples. Deep learning systems help a computer model to filter the input data through layers to protect and classify information. Deep learning processes information in the same manner as a human brain processes. It is used in technologies such as driverless cars. Deep learning network architectures are classified into convolutional neural networks, recurrent neural networks, and recursive neural networks. So these ANIs are almost similar as a neuron. Often, if you are a biology student, obviously we have learned biology in our class 10 or 12. So in that we have studied a neuron. We will see an analogy between a neuron and an artificial neural network in upcoming slide. But to sum up, artificial intelligence is to make computers work similar to human. That is a goal. Okay, so consider artificial intelligence as a goal. Then to achieve this goal, we have machine learning algorithms. Okay, and these algorithms are deep learning techniques that are analogous to human brains. Simple. uh, then comes neural networks. Well, here I was talking about this analogy. So on the top figure, we are seeing a real neuron, in real neuron that is inside a human brain. Okay, so we, if you aren't aware about the parts of a neuron, let me be clear about that. So first is dendrite. Here it's a dendrite. So dendrite is responsible to take the input of data. Okay, so it takes in sensation, touch, and then the nucleus is the processing house. So it processes it has the base, the logic code. So it processes the touch, gives a reflex or response, and then it passes on to axon. What is axon? Axon is a tunnel. So that tunnel passes on with maybe a connection between the nucleus and the output layer. Okay, the axon terminals. So it connects this nucleus to the axon terminus and carries the message to axon terminus. So what are axon terminals? Axon terminals are output layers. So these they are responsible for delivering the message. Okay. So as shown in figure. So the second part, the second image represent an artificial neural network. So which is input 1, input 2 up to n inputs which go in. This is known as first layer. The input layer is the first layer. Then the processing layer. There can be n hidden layers and processing layers. It can extend to infinity. And then these layers are responsible for the logic of the neural network. They process the information, and then the last layer outputs them. So as I explained, this is a more complex representation of an artificial neural network. Mimic neuronal signal firing structure of brain with computational processing units. So let's say here is a synapse. A synapse enters into a dendrite. Well, here we have also included the coding part, the maths part actually. W0 represents the weight, and X0 is the unit. So in the cell body, it gets processed, and after it gets processed, it is then outputted from exon. Okay. So, what are artificial neural networks? Collection of connected units called artificial neurons that is analogous to axons in biological brains. So, we learn the a, a single neuron. So, when we combine, when we collect those neurons, make a collection of them, then we get a collection that is artificial neural network, a whole network of them when organized in layers of signaling cascades, that is a flow of them is known as ANN, artificial neural network. Each neuron transmits a signal to another neuron. Neuron may have state represented by a number between 0 or 1. Variable parameters. Neurons may have a weight that varies as learning proceeds, which can increase or decrease the strength of the signal that it sends downstream. Neurons may have a threshold, that is a bias, such that it only if the aggregate signal is below or above the level is the downstream signal sent. Okay, so there are three methodologies in these slides which aren't yet taught. So, which are input? Inputs are the set of values for which we need to predict the output value. They can be viewed as a feature or attributes in a data set. So, inputs are anything we provide and expect an output for. So, I provide that I have 3 wrinkles on my left side, on my left face. So, these are the inputs I provide, and I expect that my computer recognizes that it's me every time. Okay, so next is weight. Weight are real values that are associated with each feature, which tells the importance of that feature in predicting the final value. Let's say you want to develop a model for facial recognition. What will the model focus on more? Generally, your nose, eyes, and mouth are certain features that differentiate from others, which gives them more weightage than the rest of the parts. Then comes bias. Bias is used for shifting activation function towards left or right. It can be referred to as a y-intercept in the line equation, or in other sense, it can also be referred to as an error in the dataset, which causes it to lean towards a single output. Well, my friend Vaishnavi here has explained it already well. Let's say you have a dataset of cats and dogs, but there are more number of images of dogs than cats, so the dataset appears to be a bias towards dogs images. Okay, so why is it called deep learning? Well, deep in the sense there are hidden layers. Okay, so as we know, there's the first layer and last layer. Between them, there are n number of layers. We term this as hidden layers. We don't actually consider them because that isn't our consideration. That's the computer's consideration. Okay, these are called cascading tiers for processing. So deep networks, that is 5+ layers versus shallow networks which has 1 to 2 layers. And then learning. Algorithms learn from data by modeling features and updating the probability weights assigned to feature nodes in testing how relevant specific features are in determining the general type of item. So mostly it's talking about the weightage, which I explained in last slide. So what happens in a hidden layer? So often I'm repeating this term hidden layer. But what exactly occurs in this hidden layer? So you're gonna take a look at it. So this is an example. So here are input layers. Here is the output layer, which is the last layer, and between them are hidden layer 1, 2, and 3. You consider just three hidden layers here, though there can be innumerable hidden layers between them. Okay, so the first layer, it learns primitive features, lines, edges, tiniest unit of a sound passes this info to hidden layers. So mostly first layer is responsible to take in very general basic information about the data. Then this data is then passed on to hidden layer. This hidden layer trains itself to recognize slightly more complicated features. So for let's say the first layer may take in your nose and eyes as features of your face. So second layer, the hidden layer may be responsible to count wrinkles or your acne marks, anything. Yes, that thing counts acne and wrinkles too. It's frustrating for us. And then comes the last layer. This outputs the trained model. So our face has been entered into the directory of the computer by now. First layer, sorry, yeah. So logistic regression performed and encoded at each processing unit. That is y by n, 0 of 1. This, sorry, yeah, this operation works on the first layer. Okay, now supervised and unsupervised learning. So let's say we ask the computer to train on a model. We even give it a data set. So now there can be the learning can be based on the data set. How we have given it a data set. It can be of two types. First is supervised learning. Supervised learning, as the name indicates, has the presence of a supervisor as a teacher. Basically, supervised learning is when we teach or train the machine using the data that is well labeled, classified labeled data. For example, consider we have a collection of chess pieces, okay, and we want our computer to recognize their names. In the first scenario, we have provided the machine with a collection of chess pieces and their names directly. Okay, so the computer would go on and remember that this is a pawn. It looks like this, and a king like this. In this scenario, we haven't provided. And in second scenario, this unsupervised learning. Well, first, what is unsupervised learning? Unsupervised learning is a training of a machine using information that is neither classified nor labeled, allowing the algorithm to act on the information without guidance. Find the patterns. It finds a pattern in unlabeled data. Okay, so we have provided our machine with names directly, but characteristics of those chess pieces, such as a pawn is smaller than others, that is with a cherry top, and then there's a king higher than others and has a cross at the top. Okay, so we are done with supervised and unsupervised learning. Now let's move on to neural networks. So, well, there are two types of neural networks: the convolutional neural networks and a recurrent neural networks. Well, a convolutional neural network is used to train for image recognition. So, your face recognition, a dog or cat recognition comes under convolutional neural networks, and a recurrent neural network is used for speech, text, and audio recognition. The OCR we use, the Google Lens we use, and the Google Assistant also comes under recurrent neural network. Okay, so what exactly are convolutional neural networks? Convolutional neural networks is a deep learning algorithm which can take in an input image, assign an importance, that is learnable weightage and bias to various aspects or objects in an image and be able to differentiate one from the another. The pre-processing required in a convolutional neural network is much lower as compared to other classification and algorithms. Now comes a recurrent neural network. Recurrent neural network is a sequence to sequence model, which is long short term memory. Well, recurrent neural networks are responsible for recognition of OCR. Well, what is OCR? Well, you provided a document or an image having letters, I would say, recently in Apple, they provide a functionality that is you can scan an image and it extracts all the letters, the words, and then prints it in a document file. So this is known as OCR, and it can be performed, and it is performed by recurrent neural network. And also, then we can analyze audio and video files through recurrent neural networks. Now, we will be jumping on to some technical principles of deep learning, which are sigmoid function. Well, squash values. What is sigmoid functions? So the squash values in the probability function. So sigmoid are basically binary functions. So it just takes in 0 or 2. Okay, and then there is tan function. So if you are a science student, you obviously would have learned tan in your classes, in 12 classes. So it has a range from -1 to 1 and has graphs similar to the ones showed above the figure, below the sigmoid function name. So that is tan. We represent it by any name. Let's say tan A, tan B, something. Okay. So formulate as a logistic regression problem for greater mathematical manipulation. It's the use case of sigmoid function. Then comes perceptron structure. What exactly is perceptron structure? It is a core processing unit, input processing and output unit, and it has layers of weights and biases. Sorry, it levers weights and biases. Well, what exactly is the difference between a sigmoid and a perception structure? So, a sigmoid is also binary, and perception structure is also binary. But sigmoid functions output are kind of smooth. And why do we need perceptron structure? A dumb system learn by adjusting parameters and checking against the outcomes. Then comes loss functions. Though we're going to learn loss function later on in more detail, here is a short about it. It reduces combinatorial dimensionality. And why do we need it? Loss function optimizes efficiency of solution. Here comes regression. So, what exactly is regression? Regression is a technique for investigating the relationship between the independent variables or features and a dependent variable or outcome. It is used as a method for predictive model in machine learning in which an algorithm is used to predict a continuous outcome. So basically, it just gives you an idle path for given data, a whole bunch of data. It will give an idle graph between them. Uh, so regression is kind of classified into two types: linear regression and logistic regression. Two basic types mostly. So what is linear regression? Linear regression is a regression technique which plots a straight line within the data points to minimize this error between the line and data points. It is one of the most simple and basic types of machine learning regression. The relationship between independent and dependent variables is assumed to be linear in this case. It is used to predict continuous set of values, which are house price, let's say. So as shown in figure, there is a plot of scattered points. We can see there are a few scattered points above the line and few scattered points below the line. So initially this line never existed. So we have just drawn a linear line through the graph, considering that as the optimum solution. Okay, now comes logistic regression. Logistic regression is used when the dependent variable can have one or two values such as true or false or success or failures. Logistic regression models can be used to predict the probability of a dependent variable occurring. So it predicts probabilities sigmoid neurons 0 to 1, 10 as I explained, 10 hyperbolic tangent neuron, which is from minus 1 to 1, and perceptron again 0 to 1. Sigmoid neurons are similar to perceptrons, but they are slightly modified such that the output from the sigmoid neuron is much smoother than the steep functional output from perceptron. Here comes some important methodologies. Okay, so this is backpropagation. Backpropagation is an algorithm used in artificial intelligence to fine tune mathematical weight functions and improve the accuracy of an artificial neural network outputs. So, what exactly is a backpropagation? Uh, the level of accuracy each node produces is expressed as a loss function. Let's say an error rate. This backpropagation calculates the mathematical gradient of a loss function with respect to the other weights in the neural networks. The calculations are then used to give artificial neural network nodes with high error rates less weight than nodes with lower rates. Basically, it just finds out the error rate, कौन सा नॉट एरर क्रिएट कर रहा है, कैसे कर रहा है, और वो एरर रेट कैलकुलेट करता है, एंड और वो एरर जो है ना वो लास्ट नॉट से शुरू करता है कैलकुलेट करना. So that's why it's known as back propagation. Well, as soon as we know that this node is creating an error, we give less weighted to that node. So our problem is solved. We get less error. Then comes gradient descent. Gradient, a derivative to find the minimum of a function. And what is gradient descent? Optimization algorithm to find the biggest errors. Some of the well-known errors is the minima. Most quickly, it can find the following errors: mean squared error, log loss, and cross entropy. Sigmoid neuron are similar to Oh, sorry. I think I missed out something. Uh-huh. I think that's it. Uh-huh. So, more about the gradient descent is loss function. Uh, Loss function is a way to measure whether the algorithm is doing a good job. This is necessary to determine the distance between the algorithm's current output and its expected output. The measurement is used as feedback signal to adjust the way the algorithm works. Okay, so it is basically an optimization technique, a mathematical tool used in statistics, finance, decision theory, biological modeling, computational neuroscience, optimal control therapy, etc. These are its use cases. Well, what it does is it just minimizes loss or cost, and it also maximizes. It actually eventually maximizes reward, utility, profit, or fitness. So loss function links the instance of an event to a cost. For example, an accident occurs. Well, here an accident is an event, means there's a $1,000 damage on average, so that is a cost. And a 5 centimeter a height event confers a 5% fitness advantage, so that is a reward. Also, in the bottom right, we can see some formulas. So these are some of the errors that loss function can detect, and it is its formula along with that, and also if that error is symmetric or not. Thank you very much. Looking forward if you have any doubts.
Guys, if you have any of the doubt, please feel free to drop that in the chat box. Yeah, there's a question. Can we make an AI that makes a data storage?
Sorry, what? Data storage? Yeah. Can you just elaborate your question? think that guy has actually left the live. I think that guy has left the stream. So if anyone has any other doubt, you can ask in the comments.
Well, I see your question there.
I don't think they're. Okay, just a minute. Store data. Yeah, to store data. I mean, you mean a drive? Uh, well, data storage is a hardware thing, so I don't think uh, AI can do anything in that. Thank you very much.